Hello guys, my name is Don Mancera, and today we're going to be talking about types of mixtures versus pure substances. So first of all, why we classify them? Well, anything can be classified into a pure substance or mixture. This rock can be classified, the glacier in front of it, that gentleman's watch, the coffee itself, the cup itself that the coffee's in can be classified. So first of all, real quick, some categories of it. A pure substance will either be an element or a compound, and we'll talk about that. And a mixture will either be homogeneous or heterogeneous, and we'll talk about that further down. So first of all, pure substances and their properties. They can all be separated by chemical reactions. They can be all states of matter, solid, liquid, or gas. They can either be an element or a compound. And the reason why they are an element is a pure substance is because that element is made up of a particular kind of atom and therefore cannot be broken down or transformed into another atom by chemical reaction. You always get gold no matter how further down you break it down. And a compound is two or more elements chemically bonded to form one pure substance. So some examples here we have is this iron bar here. Physically they are a little bit different, but chemically they are the same. Whether you break these down, you always get iron. Similar to these gold rings. Physically they are different to this gold flakes, but they are the same chemically. If you were to break these down, you would still get gold. And compounds, this compound, salt, NaCl, is a pure substance because you have sodium and chlorine chemically bonded together to make sodium chloride. Whether that sodium chloride is made in a lab or found in nature, they are both still the same. They are both still salt. Similar to water. Water is two hydrogen molecules and one oxygen molecule chemically bonded together to make H2O, water. Whether that water is found in nature or chemically made in a lab, if you combine those two elements, you form that compound, water. Next we have is mixtures. First we have is homogeneous mixtures. Some properties of these are that it's a mixture of two or more elements or compounds that cannot be visually distinguished. For example, we have Kool-Aid. Kool-Aid is constant throughout. It can be more difficult to separate the mixture. Some more examples we have here. Like I said, Kool-Aid. It's mixed with sugary mixture and other sorts of things. We cannot visually see which part is the sugary mixture, which part is the water. They appear as one, and it could be difficult to separate. Another example we have here is Coke or any kind of soda. Visually, you cannot see the sugary syrup or the other ingredients mixed in there, or the carbon dioxide to give it those bubbles, but they are in there and they appear as one. Another example we have here is tap water. Tap water itself has particles in it, minerals, fluoride. Even though it appears there is nothing in the water, there are still particles chemically in there. Another example is brass. Brass is an alloy. It's a mixture of copper and zinc. You cannot tell which part is copper or which part is zinc. They appear as one whole solid piece, one whole solid color. Okay, another example. Next we move on to heterogeneous mixtures. It's a mixture of two or more elements that can be visually distinguished, and it can easily be physically separated. So the opposite of homogeneous mixture. For example, we have oil and water. The oil and the water can be easily visually distinguished. This part is oil, this part is water. You can chemically remove these, and the oil's viscosity allow them to be separated. Another example we have here is sand in the water. You can see the sand in this water. If you were to grab a bucket of it, you would see the sand floating in the water, and you could physically remove it or chemically. Probably easier to physically remove it. Another example is pizza. You can visually see the different toppings, your cheese, onions, peppers, looks like ham, and you can physically separate them. So on to this activity. So you have to classify these as either a pure substance, homogeneous mixture, or heterogeneous mixture. So first one we have is bronze. So bronze will be classified as a homogeneous mixture. It's a mixture of copper and copper and tin. You cannot visually see the copper or the tin. They appear as one whole solid piece. Next we have is pure water. That's right, it's pure substance. We have two hydrogen molecules bonded to the oxygen molecule. Whether we make it ourselves or it's found in nature, if you combine those two elements to form that one compound, you will always get water. Next we have salt water. Okay, that's right, it's a homogeneous mixture. The salt and the water cannot be visually distinguished. Next we have is a meat lover's pizza. That's right, it's a heterogeneous mixture. You can pick out the toppings, you can see the cheese, the crust, whatever's on your toppings, sausage, pepperonis, all those things. You can easily physically separate them. Next we have is rose gold. That's right, rose gold is a homogeneous mixture. It's an alloy. It's gold with copper. You cannot visually see which parts are copper, which parts are gold. They appear as one whole solid pink rose color. Next we have is xenon. That's right, it's a pure substance. It's a gas. It's an element. You cannot break down xenon into anything further. You will always get xenon no matter if you have it in the gas form or the liquid form or whichever form you have. And that's it. Thank you guys for watching.